Within the silence of museum corridors worldwide, behind glass enclosures and air conditioning, artifacts that have baffled scholars for decades. These artifacts, made by civilizations that once lived long ago, hold in them messages that we are only now deciphering. Some of them have advanced mathematical ideas that should not have been present during their eras. Others preserve scripts and symbols that have defied all translation attempts. We set out today to crack the secret messages in these forbidden relics, things so enigmatic that they completely upend all we believed we understood about ancient human wisdom on a Pacific island miles from the nearest land. 2,300 miles from the nearest population stands one of archaeology's most baffling mysteries. Rapa Nui, or Easter Island, is renowned for its giant statues of stone, but beneath the island's cultural riches is something much more intriguing: a writing system that no one alive can decipher. The Rongorongo script, unearthed in the 1860s by French missionary Eugene Iraud, is what is perhaps the only indigenous writing system that was ever created in the Pacific Islands. The wooden tablets, which the islanders refer to as a kohau Rongorongo, it consists of more than 600 unique symbols in a specific pattern known as reverse burstrophiedern. Alternate lines are written in opposite directions. Similar to a farmer plowing a field, a breakthrough came in 1995, according to Dr. Stephen Roger Fisher, a New Zealand linguist born in Germany who spent decades researching these tablets, when he uncovered repeating patterns that indicated the script could be genealogical chants. Yet his interpretation is still disputed among scholars. The Rongorongo script seems to have a rigid formulaic system. What we are looking at is not haphazard symbols, but a methodical notation of information that was vital to Rapa Nui society. The mystery deepens when we consider the timing of the script's creation. Most experts believe Rongorongo developed between 1200 and 1500 CE, making it one of the world's youngest writing systems. Yet, by the time European contact intensified in the 18th century, the knowledge of how to read these tablets had already been lost. What is so tragic about this is that the disappearance of the script happens at the time of one of the greatest cultural breakdowns in history. By 1877, the Easter Island population fell from an estimated 15,000 to a mere 111 individuals, casualties of slave raids, disease, and environmental degradation. The few surviving tablets, just 26 genuine fragments, exist around the globe, can hold oral traditions, genealogies, and cultural lore of a whole civilization. New developments in artificial intelligence and pattern recognition bring fresh hope for deciphering. Yet the Rongorongo writing continues to stubbornly remain silent, its mysteries hidden behind symbols that move across ancient wood. 4,500 years ago, while Egypt's pyramids were rising, another advanced civilization was thriving on the other side of the Indus River Valley. The Harappan civilization, or Indus Valley Civilization, was one of the world's first urban civilizations, boasting complex city planning, sophisticated drainage, and units of weight and measure, but for all their domination of a terrain greater than ancient Egypt and Mesopotamia combined, the Harappans bequeathed archaeology's most agonizing mystery, a writing system that has defied all decipherment for more than a century. The Indus script shows up on more than 4,000 artifacts, mostly minor steatite seals that were used for commerce and administration. These seals, often only 2 to 3 centimeters square, have concise inscriptions of just 5 symbols on average. The script employs around 400 different signs, and this number puts it between logographic systems such as Chinese and syllabic systems such as those of Maya hieroglyphs. The shortness of the inscriptions is our biggest problem. Many of them are so short that they probably contain names, titles, or plain administrative data without extended texts, We do not have the statistical patterns required for breakthrough decipherment. The geometric form of most Indus symbols has also caused researchers to consider whether they may symbolize not only words, but mathematical or astronomical realities. Dr. Rajesh Rao of the University of Washington made a seminal computer analysis in 2009. Comparing the Indus script to linguistic and non-linguistic systems, his results implied that the Indus inscriptions share the statistical characteristics of natural language, validating the hypothesis that they are indeed writing and not a collection of pictographic symbols. Perhaps the most fascinating element of the Indus script is that it seems so standardized throughout the whole civilization. Other early writing systems that developed and altered over time, Indus symbols remained surprisingly stable for more than 600 years, which might point either to strict control over culture or to a script that was so well suited to its language that change was not necessary. Recent digs revealed what is possibly the longest Indus Valley inscription ever, a signboard at the Dalarvara site with 10 big symbols. If this is a public sign, it could give important information about how the script worked in Harappan society. The secrets of the script went with the civilization around 1900 BCE. Perhaps because of climate change that parched the rivers that supported Harappan agriculture. Now, computer programs read thousands of seal impressions, looking for patterns that human eyes may overlook. While researchers argue if the old symbols will ever reveal their secrets, in 1901, sponge divers working off the Greek island of Antikythera made a discovery that would revolutionize our understanding of ancient technology. Among the marble statues and pottery scattered across the Mediterranean seabed lay what appeared to be a simple corroded lump of bronze. It would take decades to realize that this unassuming artifact contained mechanical sophistication that wouldn't be seen again in European technology for over 1,000 years. The Antikythera Mechanism, as it would later be named, has come to be referred to as the world's first computer at around 100 to 50 BCE. This bronze machine held a minimum of 37 meshing bronze gears in a sophisticated system that was able to foresee the positions of celestial bodies with great accuracy. When we initially viewed the X-ray images with the gears visible inside, we couldn't believe our eyes. This was not meant to exist in the ancient world. The mechanical complexity was on par with 18th century clockwork. The front dial shows a 365-day solar calendar, and in the back, there are two main spiral dials that forecast lunar eclipses and the 4-year Olympic Games cycle. In perhaps its most astonishing feature, the mechanism utilizes a differential gear, a mechanical part not yet to be invented until the 16th century. Recent studies employing sophisticated imaging technology have brought to light inscriptions on almost all the surfaces of the mechanism. These writings, which are in ancient Greek, are an instruction guide describing how the device operates and reads its predictions. The inscriptions make reference to phenomena in the sky and have a calendar of Corinth month names, implying the mechanism was constructed by Greek researchers who knew about Babylonian astronomy. The finding has compelled historians to re-evaluate the technological prowess of ancient societies. The precision involved in creating such minute, interlocking gears indicates the presence of advanced workshops and a tradition of mechanical engineering hitherto unknown to scholars. Most tantalizingly, the mechanism seems to have been built for teaching, not for navigation. Its portability and ability to perform a wide range of astronomical functions indicate it was utilized to instruct the intricate patterns between celestial cycles. A professor's teaching tool masquerading as the world's most advanced ancient technology, the Antikythera Mechanism challenges us to imagine their continuity of human knowledge if these devices were present in ancient Greece. What other technological wonders were lost during the tumultuous centuries that elapsed? The bronze gears of this ancient computer still revolve in our minds, clicking through calculations that transcend the divisions between ancient and modern understanding. High in the Andes Mountains of Peru, The Inca Empire once ruled over the largest contiguous area in the Americas without the wheel. Ayan, or written language as we know it. The Inca developed a complex administrative system that effectively regulated 12 million individuals in various geography. Theirs was not mechanical record, but rather an elaborate system of knotted strings known as quipu. Quipu, or a knotty in Quechua, is a primary cord from which dangle many pendant strings of various colors, each holding distinct patterns of knots. Spanish historians of the 16th century stated that these machines were capable of registering everything from tax accounts and census information to historical accounts and spiritual ceremonies. The quipu system is a very different method for storing information instead of written symbols on a plain surface. The Inca developed a three-dimensional recording system in which they used precision, color, and type of knots to store information. The mathematical accuracy of quipu cannot be argued. The decimal system employed by the Inca means that knot precisions were used to signify units, tens, hundreds, and thousands. Various types of knots, simple, long, and figure eight, were used to signify various numerical values. This made quipu keepers, or kapukamayok, able to make intricate calculations and keep precise records throughout the empire. The latest developments in quipu studies have already shown that these tools could store much more than numeric information. Dr. Sabine Hylands, pioneering work with present-day Andean groups, has testified to narrative quipu that are still in active use today, which indicates that the system might well store complex non-numerical data. The difficulty of interpreting historical quipu is their context, while mathematical computations adhere to universal rules. Narrative content must know the particular cultural and linguistic traditions of their authors. The conquest of the Spanish interrupted their transmission, remanning hundreds of quipu whose tales are trapped in their knotted threads. Most fascinating is the discovery of quipu at the Incahuasi site. Dating around 1450 CE, the devices are evidence of systematic organization and potentially an accounting system for tribute collection. The accuracy of their construction and regularity of their knotting patterns indicate that quipu making followed strict protocols that were maintained throughout the empire. Contemporary computer analysis has revealed repeated patterns in quipu construction reflecting principles used in binary coding systems. This has spurred some scholars to suggest that quipu could be the first attempt at a three-dimensional database by humanity. Hundreds of years before such ideas developed in Western technology in Central America's rainforests, the Maya civilization attained astronomical accuracy that approaches modern computation between 300 and 900 CE. Maya astronomers monitored celestial cycles with precision that would not be equaled by European science for centuries. Their calculations, inscribed in bark paper books known as codices, hold mathematical ideas so sophisticated that they force us to rethink our conception of Colombian scientific accomplishment for Maya codices escaped the systematic destruction that Spanish Bishop Diego de Lander ordered in 1562. Those valuable books, the Dresden, Madrid, Paris, and Grolier codices, hold data on astronomical phenomena, sacred rituals, and crop cycles. The most advanced, the Dresden Codex, possesses eclipse prediction tables that match modern calculations to within minutes. The Maya estimated the solar year to be 365.2420 days, which is very close to our current measurement of 365.2422 days. That's a difference of only 17 seconds per year. In order to have been that precise, they must have been taking systematic measurements over centuries. The mathematical underpinning of Maya astronomy lies in their advanced system of numbers, including the notion of zero. Developed independent of European mathematics centuries earlier, Maya mathematicians operated with units well beyond practical requirements. computing dates millions of years ago and ahead of time, implying that their fascination with time and astronomy extended far beyond ceremonial or agricultural requirements. The Venus tables of the Dresden Codex illustrate the Maya skill at forecasting the synodic cycle of the planet, the duration between consecutive appearances in the same relative position to Earth and the Sun. Their calculated synodic period of 584 days is off by no more than 5 minutes per cycle. This level of accuracy necessitated ongoing observations that spanned multiple generations, suggesting an institutional interest in astronomical investigation. Most surprisingly, the Maya also created correction equations for their own calculations. The Dresden Codex contains correction factors for the accumulation of errors in their Venus cycle calculations, demonstrating that Maya astronomers were aware of the necessity of occasional calibration, a fact at the heart of modern scientific practice. The sophistication of Maya records of the heavens implies they had more than simply practical purposes as calendar keepers. A few scholars suggest the Maya conceptualized time as cyclical rather than linear, and that the stars and planets functioned as signs to discern cosmic pattern and divine purpose. Their codices are therefore simultaneously scientific tools and religious texts, inscribing a worldview in which mathematics, astronomy, and spirituality were indissolubly interconnected. Sealed in a climate-controlled safe at Yale University is the world's most mysterious manuscript, the Voynich manuscript, a 240-page vellum book inscribed in an unknown alphabet and decorated with strange plant drawings, has foiled decipherment attempts by some of the greatest code breakers in history, including the teams that cracked German Enigma codes in World War II. Carbon dating suggests the manuscript was written between 1404 and 1438 CE, the peak of the European Renaissance. The writing, consisting of what seems to be a uniform language composed of about 170 unique characters, reads easily over pages with the statistical features of actual human language. Still, no linguist has been able to determine the root tongue or decipher any word with absolute surety. The manuscript shows all the characteristics of a natural language, but one that conforms to grammatical rules unlike anything we've seen. This implies either an incredibly advanced constructed language or a natural language that evolved in total isolation from what we know of linguistic families. Here, the illustrations within the manuscript create another layer of intrigue. Detailed drawings in the botanical section depict plants that bear no resemblance to any known plant species. Even though they convincingly represent living things, some look like composite constructs, cobbled together from different plant families in ways that would be impossible for a botanist. The astronomical section contains circular diagrams that can possibly be calendars or astrological charts with symbols and arrangements that do not reflect any identified astronomical tradition. Most intriguingly, some diagrams depict the Pleiades star cluster with 7 stars, a detail that would need telescopic observation. Yet the manuscript is 2 centuries before Galileo first constructed a telescope. Recent computer analysis has revealed patterns indicative that the text could be organized as an encyclopedia or pharmacological handbook. The word frequencies and distribution patterns are similar to those of herbal medicine treatises of the time, which has led some scientists to suggest that the manuscript holds useful scientific information encoded in an artificial language developed to secure trade secrets. The enigma is compounded when taking into account the provenance of the manuscript. In 1912, Wilfrid Voynich, a dealer in antiquarian books, purchased it from the Jesuit Collegio Romano, but previous ownership documents extend back to Rudolph II, Holy Roman Emperor, who allegedly spent 600 gold ducats to acquire it in the early 17th century, about $50,000 by today's measure. Contemporary artificial intelligence methods have yielded mixed conclusions. Some software indicates the text as significant language, While others state it could be a massive hoax, the experts continue to debate whether Voynich manuscript holds true lost wisdom or is history's most clever literary deceit in some of the world's best laboratories. A new arsenal of technology is being applied to humanity's most ancient enigma's powerful imaging technology, computer algorithms, and huge amounts of computing power are bringing fresh details invisible to earlier generations into view, raising hope that some of archaeology's most resistant mysteries may at last share their secrets. Multispectral imaging today enables scientists to view erased, overwritten, or extensively damaged text that is no longer within normal visibility. Dr. Gregory Hayworth's Lazarus project at the Rochester Institute of Technology employs high-tech imaging to bring back lost text from palimpsests, manuscripts in which later writing has been placed on top of earlier erased text. We can now look at ink mixtures invisible to the naked eye, unearthing layers of text that reveal the history of how manuscripts were made, used, and recycled over centuries. Each palimpsest is a book-sized archaeological site. Machine learning algorithms trained on successfully deciphered ancient scripts are being applied to unsolved writing systems these programs can identify. Projects such as Transcribe Bentham engage citizen scientists in transcribing documents, and the Ancient Lives project enables volunteers to identify and translate papyri from ancient times. These crowdsourced efforts have delivered insights that formal academic studies could have otherwise bypassed, showing that new eyes and different minds can reveal patterns that experts are blind to. Digital preservation of the artifacts guarantees that future scholars will be able to reference complete records even if physical artifacts degrade or become lost. 3D scan technology generates accurate models that can be analyzed, manipulated, and examined without the risk of damaging valuable originals. The cryptic messages in forbidden artifacts are a reminder of how human ingenuity and creativity have profound roots in the history of our species. These ancient writings, machine technologies, and recording devices show that our forebears had knowledge, skills, and ideas that surprise and challenge us even now. Each of these as yet undeciphered scripts is not merely a problem to be solved, but a window into lost worlds of thought and experience. The Easter Island Rongorongo tablets may contain the oral history of Polynesian navigators. The Indus Valley seals could contain the everyday worries of Bronze Age traders. The Inca Kipu can contain epic poems and historical accounts on par with written literature. Our digital tools provide unrivaled potential for unlocking these secrets of the past, but they also serve to remind us that decipherment involves more than brute force computation. It takes cultural sensitivity, linguistic knowledge, and profound historical awareness of the worlds in which the artifacts were made. The search to unlock humanity's lost languages and forgotten systems of knowledge continues to propel scholars in various fields. Each advancement not only provides us with information about the past, but also offers a glimpse into the very human drive to document, conserve, and pass on knowledge from one generation to the next. As we create increasingly powerful aids to analysis and interpretation, we can anticipate that these forbidden objects are not forbidden after all, that they merely await our acquiring the wisdom and patience to realize what our ancient predecessors were seeking to communicate. Their secret messages, locked in symbols, knots, and gears, still draw us along the path to a greater knowledge of human capacity and the abiding power of inquiring minds to close the breach between yesterday and today. The dialogue between ancient intellect and contemporary science goes on, in terms of the universal languages of mathematics, astronomy, and the boundless human quest to comprehend our position in the universe. In deciphering the secret messages, we learn not only what our forebears understood, but also what they imagined, dreaded, and envisaged about the future. Now a past that stretches toward mysteries still to be unraveled, the secrets encoded within these artifacts wait for our comprehension, as steadfast as the rock on which they were inscribed, as long-lasting as the human spirit that wrote them, and as timeless as their questions they raise about what it is to be human.